penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bervisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Sirih berlipat, sirih pinang berasal dari Pulau Mutiara. Pemanis kata selamat datang. Assalamualaikum. Pembuka bicara. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Madani dan selamat datang ke Pusat Tuisyen Online PERCUMA dibawakan khas untuk anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia. Bermula percuma, selamanya percuma. Saya Cikgu Hasnitah, presenter anda pada hari ini yang kini berkhidmat di SMK Bagan Jaya Butterworth Pulau Pinang. Jadi insya-Allah pagi ini kita akan sama-sama belajar tajuk yang seterusnya untuk Fizik Tingkatan 5 bagi kelas DLP dengan tajuknya 2.2 Atmospheric Pressure. Jadi sebelum kita mulakan kelas pada hari ini, ayo kita buka majlis ilmu kita dengan bacaan Ummul Kitab Al-Fatihah dan doa belajar. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada pagi ini mendapat siraman rahmat pada Allah Subhanahu Wa Taala. Okey, sekali lagi selamat datang. A very good evening to everyone and welcome to our free online tuition classes brought to you by Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia. Okey, jadi seperti biasa sebelum cikgu mulakan, anda bolehlah dapatkan dahulu PDF copy untuk modul yang cikgu akan gunakan pada pagi ini. Boleh klik saja pada link ini, print keluar secara percuma sahaja. Pautan ini juga boleh didapati pada video deskripsi di bawah. Okay. Okay students, so if you are good and ready to go, so before we begin with our lesson today, let us first introduce my committee members, physics panel in Akademi Youtuber. Ini adalah barisan guru-guru sukarelawan fizik di Akademi Youtuber Malaysia yang telah banyak membantu saya untuk menerbitkan video-video PDPC sama ada untuk kelas DLP maupun bukan DLP. Dan di mana anda boleh dapatkan video-video ini, anda boleh muat turun apps Akademi Youtuber di Android anda sekarang. Apa yang kita ada dalam apps ini sehingga hari ini, kita ada lebih kurang 28,000 video PDPC daripada peringkat prasekolah hinggalah ke pra-universiti yang anda boleh gunakan sebagai bahan rujukan tambahan untuk pembelajaran anda. Jadi muat turun sekarang Akademi Youtuber apps. Okay, so students, without any delays, without further ado, let us begin our lesson today with 2.2 atmospheric pressure. So in your textbook, this topic is covered from page 49 until page 45. Before that, you can say hi, especially for those who newly join my class, siapa yang baru pertama kali sertai kelas Cikgu Hasnitah, anda boleh say hi dulu, boleh perkenalkan nama siapa, dari sekolah mana, negeri mana. Alright, okay, dan anda boleh share juga link kelas ini kepada rakan-rakan yang lain. Mudah-mudahan lebih ramai lagi yang dapat memanfaatkan apa yang kita bincang pada hari ini. Alright students, so atmospheric pressure, kita ada Cikgu Kok di sana, long time no see. Cikgu Kok, hai. Selamat Tahun Baru Cina, Cikgu Kok. Harapnya belum terlambat lagi lah untuk saya ucapkan. Okay. Semoga Cikgu Kok sentiasa sihat bersama keluarga yang tersayang. Okay students. So atmospheric pressure, this is the second content standard in chapter 2 form 5. So if you remember last week we have discussed 2.1 pressure in liquid. So on atmospheric pressure altogether we have 4 learning standard. Ada 4 standard pembelajaran keseluruhannya. Right, yang pertama, the first one is to describe atmospheric pressure. So student, after learning this, you must know what is meant by atmospheric pressure. And second is to communicate about the value of atmospheric pressure. What is the value of atmospheric pressure and in what unit we write atmospheric pressure at. And third is the most important one, is to solve problems in daily life involving atmospheric pressure. And last but not least is to study or to look at what is the effect of atmospheric pressure on object at high altitude or underwater. Okay, so this will be our learning standard that we will cover and discuss for today. Okay. Okay, student, I believe for those who have learned this in school, you have conducted a few activities with your teachers. So this is one simple example of activity you can conduct at home, actually on your own. So in this activity, our aim is to discuss atmospheric pressure from the aspects of the weight of air acting on an object at the surface of the earth. All right, so if you look at this diagram, okay, so you only need two things, glass and also a cardboard. Okay, glass and also a cardboard and of course water. Okay, so all this I think you can find at home, or if you don't have any cardboard, you can use any hard paper. All right. Okay. So how to conduct this activity? First, you need to fill a glass with water until it almost full, and place a cardboard below. Okay, below the glass as shown in this diagram. And all student, by supporting the cardboard on top of the glass, slowly invert the glass. So you topple the glass. So now the cardboard will be on top. Okay. The cardboard will be on the bottom, sorry. Okay, so now you slowly remove the hand supporting the cardboard and see either the cardboard fall or not. Okay, fall down or not. And when you conduct this activity, this is the observation you should have. Okay, anda akan dapati cardboard itu tidak jatuh, air juga tidak mengalir keluar. You will observe that the water in the glass does not flow out while the cardboard does not fall. So how to explain this? Macam mana kita nak jelaskan why the cardboard does not fall? Student, this is because the atmospheric pressure act on the surface of the cardboard is greater. Okay, atmospheric pressure from this direction is greater compared to the weight of water acting downwards inside the glass. So this will produce an upward resultant force, thus prevent the water from fall out or prevent the cardboard from fall. Okay, that is the explanation. And I have short video to show you the demonstration of this activity. So let's take a look at this video. So this is the explanation for this activity. Okay, interesting, right? There's nothing magic, all to do with physics, atmospheric pressure. Okay, that is the first video for the first activity. Okay, now let us take a look at the second example. Okay, the second activity. This one also you can conduct at home, but you have to be very careful as you are going to deal with the hot water. All right. So in this second activity, also to discuss the atmospheric pressure from the aspect of weight of air acting on the object on the earth surface. So all you need is an empty plastic bottle a hot water and a cold water, and of course a basin to conduct the activity on. So student, if you look at this diagram, we only need 2 steps to conduct the second activity. The first one, you fill an empty plastic bottle with half water until about with hot water until about quarter full. Okay, so if you are using 500 milliliter bottle, so it is about 125 ml. Okay, then after you pour the hot water into the bottle, immediately close the cap. Okay, and then you can pour cold water around the bottle. Okay, around the bottle, and wait for a few seconds. See what happened to the shape of the bottle. So what do you think happened to the shape of the bottle when we pour cold water around it? Okay, you can give your reply in the chat, in live chat as well. All right. So this is what you are going to observe, student. The bottle will crush or the bottle will contract. Okay, after we pour a cold water around it. So how to explain this? What happened? Why the plastic bottle contract? Anyone can explain? Kenapa dia menjadi kemik apabila kita tuang air sejuk ke atas botol yang telah berisi dengan suku air panas, suku daripada isi padu botol. Yeah, very good. So this is how we explain. First, when you pour a hot water into the bottle, so the steam from the hot water drives out the air from the plastic bottle. Bila kita tuang air panas, steam pada air panas dia menolak udara yang ada dalam botol keluar. And then what happened? We close the cap quickly to prevent outside air from entering back to the bottle. Kemudian kita tutup botol dengan cepat untuk elakkan udara yang dah keluar tadi masuk semula ke dalam botol. And then third, what happened when the cold water is poured around the bottle, the steam inside the bottle will condense to water and create partial vacuum inside the bottle, which means lower pressure inside the bottle compared to the atmospheric pressure outside. So bila kita tuang air sejuk ke sekeliling botol, apa jadi pada steam dalam botol? Dia akan terkondensasi menjadi air dan mewujudkan separa vacuum dalam botol. Maksudnya tekanan dalam botol sekarang lebih rendah daripada tekanan atmosferik di luar. So by that, the atmospheric pressure outside, which is greater, will press the bottle inwards, will compress or crush the bottle. That's why you can see the shape will be contracted. So tekanan atmosfera yang tinggi di luar akan menekan botol ke dalam, menyebabkan dia menjadi kemik. So that is the simple explanation for this activity. Now let us take a look at the video for activity number 2.
Do you know that air can crush things? You do not believe me? Let me show you. Take some boiling water and pour it into a plastic bottle using a funnel. Do not fill it completely, just a little less than half the bottle. Cap it tightly. Now pour cold water over the bottle and watch it get crushed.
See what happened? The bottle crushed.
What happened here? When the boiling hot water was poured into the bottle, the steam pushed some of the air out. At the same time, the air above the water surface was heated and hence expanded. This also pushed some of the air out, and the amount of air inside the bottle reduced. Then when we capped the bottle, the air could not enter back in. Finally, when we poured cold water over the bottle, the steam condensed to water and the air cooled and contracted. This led to lowering of air pressure inside the bottle. As the air pressure inside the bottle fell significantly below the pressure exerted by the air on the outside, the walls crashed in. Air in the pneumatic tires in our bicycle or cars exert pressure on the walls of the tires from inside.
Okay, so I hope you are clear with the explanation for this activity. So for the first activity, the cup with cardboard, and second activity, the plastic bottle and hot water. Interesting, right? So you must try this either in laboratory in your school, or you can try also at home. But please be careful when you handle with the hot water. All right. Okay, next students, let us, that is the introduction or the induction set for this lesson. So now let us go to the first learning standard to describe what is actually atmospheric pressure refers to. So from the two example I give you just now, okay, and also according to this GIF I show you here, this is our globe, this is our earth where we are living at. And if you notice, this is the layers of air around the earth. All right. So what is meant by atmospheric pressure? So actually atmospheric pressure refers to the pressure due to the weight of the layer of air which act on the surface of the earth. So if you look at this animation, the layers of air contain molecules, so they have weight, and this weight acting on the earth surface from all directions, so it exerts atmospheric pressure on earth surface. Okay, so the blue word is the key word for definition for atmospheric pressure. So again, what is atmospheric pressure? It is a pressure due to the weight of layer of air acting on the surface of the earth. Apa maksud tekanan atmosfera? Dia adalah tekanan yang disebabkan oleh berat udara. Okay, berat udara yang bertindak ke atas permukaan bumi. Alright? Okay. And students, okay, if you look at this slide now, how does atmospheric pressure change with the changes of altitude? Bagaimana tekanan atmosfera berubah dengan perubahan altitude? What is altitude? Altitude mean height from sea level. Altitude adalah ketinggian daripada aras laut. Alright, so if you look at this example, what happened at the sea level? Okay, the blue dot represent the air molecule. Okay, at sea level, we have a lot of air molecule there. Sea level ni keadaan kita di biasa ni, di ketinggian yang biasa. And when you climb up at the higher altitude, you can see the number of blue dot decreases. Mean the number of air molecule decreases. So we understand when the number of air molecule increases, so the weight of air molecule acting on that area also decreases. So which mean less pressure will be acting on at higher altitude. All right. So from here we understand as altitude increases, atmospheric pressure decreases. Apabila ketinggian dari aras laut bertambah ataupun altitude bertambah, maka tekanan atmosfera akan berkurang. Alright? Okay. And then next student, okay, itu saja the first learning standard done. What is atmospheric pressure, and then how does atmospheric pressure change with altitude? Okay, now let us go to the second learning standard to communicate about the value of atmospheric pressure. So how much is the value of atmospheric pressure acting on an object on the Earth's surface? So if you look at this symbol GIF, atmospheric pressure at sea level is at 1 atm. Okay, atmospheric pressure at the sea level is equal to 1 atm, 1 atmosphere. So this 1 atmosphere also equal to 1.01 times 10⁵ Newton per meter square. Okay, and also equal to 1.01 times 10⁵ Pascal. Okay, also equivalent to 10.3 meter water. Mean if you are dive at the depth of 10.3 meter water, the pressure down there is equal to 1 atm. The pressure down there is 1 atm or 10.3 meter water. Also equivalent to 76 centimeter mercury or 760 millimeter mercury, and also equal to 1.03 bar. So here we learn that atmospheric pressure can be written in various units, and the standard unit is in Pascal, okay, or Newton per meter square. Okay, 1 atmosphere. Okay, then students, okay, now what instrument we can use to measure atmospheric pressure. Apa nama alatan yang boleh kita gunakan untuk mengukur tekanan atmosfera? So the first one is called as 14 barometer. Actually, this apparatus used to come out in the SPM question a few years back. Dia pernah keluar dalam soalan SPM yang berbentuk esei 10 markah. Alright. Okay, this is the structure of 14 barometer. On top, we have a vernier scale up there, and at the bottom, we have mercury level adjustment screw. Okay, so how to use this 14 barometer and what is the advantages or disadvantages of 14 barometer compared to any other apparatus? Okay, first, the value of atmospheric pressure is determined by the changes of height of the mercury column. So here we have a mercury column. So the changes of height in the mercury column will determine the atmospheric pressure at that place. Okay, and student, this 14 barometer, it is bulky. It is larger in size and not portable. So this is one of its disadvantage. It is larger and not portable to be carried here and there. Mean it normally used in a one place only. And another disadvantages for 14 barometer, it takes longer time to give the reading of the atmospheric pressure. Dia memerlukan masa yang lama untuk kita mendapatkan bacaan tekanan. But the advantage is it has a higher accuracy. Kelebihan dia mempunyai kejituan yang tinggi. Okay, which is up to plus minus 0.1 millimeter mercury. So who's using 14 barometer to measure atmospheric pressure? So usually used to measure atmospheric pressure at the meteorological center, di Pusat Meteorologi. Alright, okay. Next we have aneroid barometer. Ini yang kedua, kita ada aneroid barometer, aneroid. Alright. So this is the structure of aneroid barometer, and this GIF shows how it's function. Alright. So for aneroid barometer, the value of atmospheric pressure is determined by the changes in the volume of the partial vacuum metal box. So dalam ni dia ada partial vacuum metal box. Alright. And the box expand and its volume increases when the atmospheric pressure decreases. So when you put them in a area with a lower atmospheric pressure, the volume inside the metal box will expand. Alright. So the box and opposite thing happen. The box will contract and its volume inside decreases when atmospheric pressure outside is greater. Alright. So students, how we determine the reading of the atmospheric pressure? A slight movement of the box, which is magnified by a level system, connecting to a scale pointer. So the pointer will give us the reading of the atmospheric pressure on that place. Alright, okay. So this is another characteristic for aneroid barometer. This is the advantage of aneroid barometer compared to 14 barometer. It is smaller in size and portable, lighter, so easily to bring here and there. Okay, dia lebih kecil, so boleh dipindahkan ke sini dan ke sana. And then it give a direct reading for atmospheric pressure. Ini juga kelebihan yang kedua. Dia baca dengan cepat berbanding dengan barometer 14 tadi. Okay, but it has lower accuracy. Tapi kelemahan dia, dia mempunyai kejituan yang rendah. Okay, plus minus 1 millimeter mercury. Alright. And this aneroid barometer, where to use at? It is suitable to be used in homes, ships, and airplanes to obtain a quick reading for the atmospheric pressure. Sesuai digunakan di rumah, navigation for ship, kapal laut dan juga kapal terbang. Okay. And who else using aneroid barometer? Mountaineers, pendaki gunung. Mereka gunakan aneroid barometer as an altimeter. Selalunya pakai pada pergelangan tangan. Dia kelihatan seperti jam. Okay, use an altimeter to determine the altitude. So they will know how much oxygen supply in that area. Alright? Okay. Okay, next student, the third Okay, the third apparatus, we have simple mercury barometer. Okay, as its name, it has a simple structure as well. Okay, if you look at this diagram, a simple mercury barometer consists of a mercury column down here, mercury container down here, and also a tube column containing mercury inside. All right. So atmospheric pressure will act on the surface of the mercury as you can see in this diagram. Okay. So what happened? Atmospheric pressure acting on the surface of the mercury in the container. So what happened? It will push the mercury onto the tube. So the level of the column will be rise up and the reading will be equal to the atmospheric pressure reading outside. Okay, as shown here, the height of the mercury column depends on the magnitude of the atmospheric pressure. All right. Okay. Then students, all right, talking about simple mercury barometer. Okay, just now if you look from this diagram, okay, this level from the surface of the mercury in the container until this end, normally we label with H, okay, the height of the mercury column. And this height of the mercury column will determine the atmospheric pressure at that place, okay. So the height of mercury column H will remain unchanged under this situation. Okay, means if you are using a diameter of glass tube, either larger or smaller diameter, the height of H does not affect. The size of the diameter of glass tube does not give any effect on the pressure reading. Second, when the glass tube in the container is lifted or lower. Okay, so this is the container supporting the mercury. Either you lift up the column or you push it down, so H level will remain unchanged. It will be still the same according to the atmospheric pressure outside. And third situation, if the glass tube in the container is tilted, okay, this is the glass container supporting. So now you tilt the glass tube, okay, you tilt it at a certain angle. Again, the value for H does not changes. It will remain. And the fourth situation, when the volume of the mercury in the container increases or either you put in more mercury into the container or you take out some, again, the level of H will remain the same. All right. Okay, student, when H will be decreases then? It will be decreases under these two situations. First, when the vacuum space above the mercury is filled with gas. So now when you inject some gas at the vacuum surface on top, so now gas pressure will be applied on the mercury, so it will push the mercury down. So then H will be decreases. Okay, or when you bring the barometer to the peak of a mountain. Yeah, when you bring the barometer on the peak of a mountain, as we learned before, at the peak of a mountain, we have less air molecule, which means less weight of air acting on that surface, so produce lower atmospheric pressure. So lower atmospheric pressure, H will be decreases, show lower atmospheric pressure. Okay. Then when H will be increases, bila pula bacaan H akan meningkat? When we bring the barometer deep down the sea. Bila kita bawa barometer ini masuk ke dalam air. Kita tahu di dalam air itu tekanan akan bertambah dengan kedalaman. Okay, so by that, more pressure will be acting on the surface. So more mercury liquid will be pushed inside the column. So it will causes the level of height H will be increases. So I hope you are clear with this table when the level of H will remain unchanged, when it will decreases, and when it will be increases. So you can screenshot this table for your references. And also don't forget, for those who just join us, sebenarnya anda boleh dapatkan modul PDF copy, student copy apa yang cikgu bincang pada hari ini. Just click on this link I show in the screen just now, and the link also provided in the video description below. Alright, so you can print out just for free. Keep it as your additional module for this topic 2.2, atmospheric pressure. Alright. Okay, so I've done with the 2 learning standard. So now let us take a short break before we continue with the next one. Jangan ke mana-mana, kita rehat sebentar saja. Kembali lagi selepas ini. Okay student, I'm back. So saya baru bersama dengan saya Cikgu Hasnitah dari SMK Bagan Jaya, Butterworth, Pulau Pinang, dan anda sedang mengikuti kelas tuisyen online percuma bagi Fizik SPM untuk tajuk tingkatan 5 untuk kelas DLP 2.2 atmospheric pressure. Okay, so now let us continue with our discussion on the 3rd learning standard. This is the most important one to solve any problem involving atmospheric pressure in our daily life. Okay, please work together with me. If you get the answer, you can share them in the live chat as well. Kalau anda dapat jawapannya, kita kira bersama-sama. Jangan malu, jangan segan, kongsikan jawapan anda pada ruangan chat di sana. Alright, student, we have our first question there. You are given 3 diagram. It is the same tube containing mercury liquid inside and also a trap air, but we place them in 3 different positions. Okay, so your task is to find the pressure of the trap air in each column in a unit of centimeter mercury. So anda kena hitung berapakah nilai tekanan udara yang terperangkap dalam kolom dalam unit centimeter mercury untuk ketiga-tiga case ini. Alright. So the first case, we place the column, we place the tube horizontally. So this is our trap air and mercury liquid here at the length of 15 cm. Okay, so and atmospheric pressure is given 76 centimeter mercury. Okay, this is the value for atmospheric pressure. 1 atm equal to 76 centimeter mercury. Okay, what is the answer for the first case, first position here? We put in a horizontal position. So by this, the pressure of the trapped air, the pressure of the air will be equal to the atmospheric pressure, student. Atmospheric pressure acting, okay, here on top. So it is 76 centimeter mercury, okay, easy. What about the second situation? Now we put the tube in an upright position. Kita letakkan tube sekarang secara menegak. So the trapped air will be down here and the mercury liquid will be on top. Same with the height of 15 centimeter. Okay, so how to find the value of the pressure of the trapped air down here? So if you understand pressure acting up here, atmospheric pressure acting on top of this column, and in here we have pressure due to the mercury liquid. So you have to find the sum of these two pressure to determine the total pressure acting on the trapped air. So pressure acting on the air is equal to the atmospheric pressure plus the pressure due to mercury column. So how? Atmospheric pressure 76 centimeter mercury plus mercury column H 15. So answer will be 91 centimeter mercury. Okay, 91 centimeter mercury. Okay, now what if we invert the tube now? Sekarang kita terbalikkan pula tube itu. Berapa pula bacaan tekanan udara di atas ni? Alright, so by this position, the pressure of the trapped air now is the subtraction of the atmospheric pressure to the pressure due to mercury column. Okay, so now atmospheric pressure 76 minus with the length of the mercury column, which is 15, so will give us 61 centimeter mercury. So from here we can see that when we place the tube horizontally, the pressure will be equal to atmospheric pressure 76. When we place the tube in an upright position, the pressure of the trap A will be greater than atmospheric pressure, in this case 91 centimeter mercury. And when we invert, when we invert the tube, kita terbalikkan tube, the pressure will be, the pressure of the trap air will be lower than atmospheric pressure, in this case 61 centimeter mercury. So if you are clear with this first question, you can type number 1 in the live chat. Kalau anda faham soalan nombor 1 ni, bolehlah type nombor 1 dekat live chat sana. Alright, thank you for your response. Okay, now let us move to the second question, student. Tengok pula soalan yang kedua. Okay, you are given this diagram, the apparatus which is used to measure atmospheric pressure. Okay, diagram shows arrangement of apparatus used to determine the atmospheric pressure in a laboratory. Okay, the length of the glass tube is 100 cm. The total length of the glass tube here is 100 cm. And atmospheric pressure in the lab is given 76 centimeter mercury. So this is the two information you are given with. Okay, first, name the apparatus as shown in the diagram. Namakan alat yang ditunjukkan dalam gambar. Apa nama alat ini? What is the name of this apparatus, student? Yes, very good. Okay, it is simple mercury barometer. Okay, barometer mercury ringkas kalau dalam bahasa Melayu dia. Okay, simple mercury barometer. Okay, now name space P on top. Okay, name space P. Okay, so we learn from the previous slide, space P will be vacuum. It is vacuum space. Okay, vacuum space. Why it should be vacuum? Because we don't want any gas or any liquid affect the pressure value. Okay, then what is the value of H, student? Okay, this is H from the end of the mercury level here to the surface, J. So what is the value of H? So if you understand the discussion earlier, H will show atmospheric pressure reading. So the value should be equal to the atmospheric pressure given 76 centimeter. Okay, or if you want to put in meter, it will be 0.76 meter. Or if you want to put in millimeter, it will be 760 millimeter. So here 76 centimeter. Okay, now C2. Why? Give one reason. Why don't the mercury column drop until it reach the level of the mercury in it? Why this level remain? It doesn't drop back to the mercury dish down here. So if you understand, okay, there is atmospheric pressure acting in this direction. Okay, the atmospheric pressure is pushing the mercury in the surface, so it will remain there. Okay, so the mercury column supported by atmospheric pressure acting on the surface of the mercury dish. This is the reason why it does not fall and remain in the column at the height of 76 centimeter, equal to the reading of the atmospheric pressure outside. All right. Okay, next, question D. Okay, question D, students. Can you determine the pressure acting at point J and point K? What is the pressure at point J? Point J is on the surface here, point J. What is the pressure acting here? And also the pressure acting here, K. K is 15 centimeter from the surface. Alright, can you calculate them? This is an easy calculation, does not need a calculator as well. Kira dengan jari saja boleh dapat jawapan. Okay, tell me what is the pressure at J and pressure at K. Okay, so pressure at J equal to atmospheric pressure 76 centimeter mercury. Okay, what about the pressure at K? So you have to understand there are two types of pressure acting on point K. First is atmospheric pressure from top. Second is the pressure due to liquid at this depth of 15 centimeter. So we have to plus them. 76 plus 15. So the pressure at point K will be 91 centimeter mercury. Okay, easy, right? Okay, now question E. What will happen to the value of H? So this one is referred to the table I showed you just now. Okay, if you can understand the table, when H will be changes, when it will be remain. Okay, so first case, the tube is lifted at the height of 3 cm. Okay, we lift this tube up at the height of 3 cm. Will H changes? Will it decrease? Will it increase? Will it remain? Yeah, very good. The answer is it will be remain unchanged, still 76 centimeter. Now the tube is tilted at 10 degree to the right. You tilt, okay? This is the original position of the tube, which is upright. Now we tilt it about 10 degree to the right. So what do you think will happen to the H? Will be unchanged or remain? Yes, very good. It will stay unchanged. Tidak berubah. Still 76 centimeter. Measure from this end to the other end. Alright? Okay, to the surface. Okay, then the apparatus is now submerged into the bottom of a lake. We bring this down to the bottom of a lake. What do you think will happen to H? Pressure down there higher or lower? That is what you must understand first. So pressure down there at the bottom of the lake is higher. So it will add pressure. So it will add the height of the liquid column. So H now will be increases greater than 76 centimeter. Alright. Okay, now fourth case, the tube is lowered at the depth of 5 cm. Okay, now this tube, we push it downwards. You push this tube, okay, at the depth of 5 cm. Will H change? Will H change? The answer is no. Yes, it remain unchanged. Okay. Now the apparatus is placed. We bring the apparatus now on top of a mountain. We put it on top of Mount Everest or Mount Kinabalu. Student, or in Penang, we bring it to the top of Ceruk Tok Kun. Alright. So what happened to H? Yeah, very good. So we understand the pressure at the higher altitude places is lower. So the length of column H will also decreases, showing lower atmospheric pressure. Yes. And now, okay, what if there is a water vapor in space P? Initially it should be vacuum. Okay, so what if now there is a water vapor in space P? So the water vapor will apply pressure to that point, so it will push the mercury level downwards. So definitely the value will be decreases. So now H will be decreases. Okay, so this question E is to understand the changes that will happen to H when we place the tube in a different situation. Alright, okay. Next. Okay, this is the fourth learning standard, our final learning standard. Before we go and look some example of SPM, past year paper, and also formative question 2.2 in your textbook. Alright, okay. Now this is the effect of atmospheric pressure on object at high altitude and underwater. Okay, on the left side, at higher altitude. Okay, what happened at higher altitude? First, student, you must know, at higher altitude, the temperature of air is lower. Then also the density of air is lower. Hence, the frequency of collision of air molecule is lower and the air molecule moves slower. Alright, so as the result, atmospheric pressure is lower at higher altitude. That is the explanation why atmospheric pressure is lower at higher altitude. Okay, but then what happened below sea level? Apa pula jadi pada kawasan yang di bawah daripada aras laut? Okay, below sea level. So first, you must understand pressure exerted on the object in the water. Okay, there are two types of pressure acting on an object which is underwater. First is atmospheric pressure floating to the surface of the water. And second, we have a water pressure, which is due to the depth of water. We learned this in 2.1 before, pressure in liquid. Okay. So the actual pressure acting on an object underwater is the sum of this atmospheric pressure and water pressure or liquid pressure if you are using other liquid than water. All right. And pressure exerted on an object will increase when the depth of the object increases. So as depth of water increases, so pressure of liquid increases. So definitely the actual pressure will be increases as well. All right. Okay. Okay, then student, due to this difference of altitude in a top of a mountain and in a deep sea, so this is the adaptation that should be done, okay, by the mountain climbers and the airplane. So to suit the condition up there. So first, as a mountain climbers, they must do a physical trainer before climbing. So this is a must, okay, to gain stamina and to practice their breathing in a lower altitude. All right. Equipment such as smartwatch that can measure altitude, blood pressure, and body temperature also must be prepared as well before the climbing. Climb at slow rate. Okay, they must climb at slow rate, slow pace. All right. This is to allow the body to adjust the changes in pressure. So the pressure inside the body does not change drastically. If it happen, it will cause us problem to the climbers. Okay, and they must drink water even they are not thirsty. This is to prevent dehydration to the body. All right. Okay. And then for the airplane student, untuk kapal terbang pula, what adaptation they must do? Apa perubahan atau adaptasi yang perlu dilakukan? First, the pressure inside the aircraft cabin will be increased to match the sea level pressure. Okay. And then recycle the air in the cabin so that it will fresh and contain adequate oxygen level, and to remind passenger to drink enough water to prevent dehydration during the flight, especially for long distance flight. All right. And if you read at the info gallery down here, which is took from your textbook, okay, at the summit of Mount Kinabalu. Okay, if I can enlarge this for you, the info here. Okay, at the summit of Mount Kinabalu, the atmospheric pressure is about 60% of the atmospheric pressure at sea level, 60% only. Okay, and at this level, at the level of commercial air flight craft, atmospheric pressure is only quarter of the atmospheric pressure at the sea level. So you can imagine, okay, the pressure different between on top of a Kinabalu summit and at the position of the airplane compared to the pressure at the sea level. And as for astronaut student here, the outer space in the space outside the Earth atmospheric pressure. So the pressure in the outer space is almost zero. Okay, pressure in the outer space almost zero. Why? Because we don't have any air molecule there. So no air molecule, no weight acting. So almost zero. Okay, pressure in the in the outer space. So the spacecraft that carries astronaut need to do what? So first, pressurization of the spacecraft cabin to match with the atmospheric pressure on the Earth. So the astronaut do not need to wear a pressure suit while they are in the spacecraft cabin. All right. And then second, installation of oxygen generator to supply enough oxygen to the astronaut. And third, to supply a pressure suit to be worn by the astronaut when they exit the spacecraft in order to balance the pressure in the body. So this is the safety measurement taken by the mountain climbers, by the aircraft crew, and also by the astronaut, all right, to prevent any catastrophe due to the difference in pressure, atmospheric pressure. All right. Okay, now student, what about underwater? Okay, this is some adaptation made by the diver or made on the submarine which is operate underwater. Ini adaptasi untuk operasi di bawah laut pula. Okay, oleh kapal selam ataupun oleh para penyelam. Okay, first, submarine must be built from a very thick material, thick and strong material to withstand high pressure at the greater depth. Okay, while a diver, okay, this is safety measures which must take by a diver. Diver wear a special suit to protect their body from higher pressure at the seabed. Okay, slowly ascend to the sea level. So this is to prevent nitrogen bubble from form inside the tissue or blood vessel. All right. Okay. So there's an info gallery here. If you read from the info gallery here, a diver who dived to a depth of 30 meters in search of pearl oyster experienced a pressure of 4 times the normal atmospheric pressure. In some places in the world, especially in Sabah, we have some divers from the Bajau Laut ethnics. Okay, they can dive without using a oxygen tank. So that is amazing to me. Okay, students, submarine moving while for submarine, as it is moving to a depth of 250 meters, it will experience a very high pressure, which is 25 times pressure at the sea. So this is some trivia or some info that you can add to your knowledge. All right. Okay. Then, okay, so done with the learning standard. We have covered the first, second, third, and fourth learning standard. Okay, now it's time for exercises. Okay, so let us try this question together. Mari kita cuba latihan ini bersama-sama. If you can follow what I discussed to you just now, I believe there will be no problem for you in answering all these questions. Okay, first we have diagram 2.1 and 2.2. It shows the glass filled to the top with water and covered the piece of cardboard. Then it is inverted and lifted as our first activity in the beginning of this lesson earlier. Diagram 2.2 shows the glass filled to the top with water and inverted in a water-filled container. Okay, this one, we'll just lift it like that. For second, we lift it inside a container containing water. Okay, so first, name the physics concept involved in both situations, students. So what physics concept applied here in this question? Yeah, it is atmospheric pressure. Why the cardboard does not fall? Because atmospheric pressure acting on it. Okay, so answer, atmospheric pressure is the concept. Okay, second, now you compare these two diagrams, 2.1 and 2.2. What is the similarity between the situation of the glasses? What similarity happened to the glasses in 2.1 and in 2.2? So you can say the cardboard and container in both diagrams does not fall. Or you can say the water does not flow out in both diagram, or the same atmospheric pressure acting on both diagram. Okay, then explain why. Okay, how do we give explanation? So for the explanation, we can say the atmospheric pressure act at the bottom is greater than the weight of water inside the glass. Okay, so this produce an upward resultant force, thus prevent the water from flow out or prevent the cardboard or prevent the container from fall. Okay, the same explanation due to our first activity at the beginning of this lesson earlier. All right. Okay, now can you give two application that is use the concept of physics stated in B? Okay. Name two application that use the concept of physics stated in 2B. Okay, so first, you can see the same effect when using a plunger and also when using a siphon. Okay, siphon we have used in 2.1 before. So you can check back on that lesson, plunger or siphon. All right. Okay, next question. Okay, this is an example of essay question, a modification on submarine. Okay, modification on submarine. So this is diagram 2. It shows a submarine used by Navy to patrol the ocean. Okay, you have to suggest and explain how to build a submarine which can navigate with a higher acceleration in water and able to control its position. Mean it can submerge and diverge. Okay, in your explanation, you have to emphasize these three aspects. First, the characteristic of the submarine body. Apa ciri-ciri ciri-ciri badan kapal selam. Second, the number of propellers used. How many propellers? Must be more or must be less than shown in diagram. Third, the component used to control the position of the submarine in water. Apa komponen yang boleh kita gunakan untuk kawal kedudukan kapal selam? So, dia boleh naik ke atas ataupun turun lagi ke dasar laut yang lebih dalam. Alright, 10 marks for this modification. So, as usual, we prepare a table of characteristic and reason. Okay, so first, the body. Second aspect, number of propellers. Then component used. Okay, for the submarine body, you can give more than one aspects. Okay, first, in terms of material. So we can say use strong material for the submarine body. Why use strong material? Easy, so it not break. Dia tak pecah. It can withstand high pressure, tahan tekanan yang tinggi. Second, still due to the submarine body, aerodynamic shape. Okay, aerodynamic shape or streamline shape. Okay, why? So to reduce water resistance, so it will have higher acceleration as required in the question. Okay, and third, still in the submarine body, low rate of rusting. The material is made of material with low rate of rusting or low rate of oxidation material. Why? This is to prevent oxidation. Okay, so it does not rust, it does not oxidize, or the submarine will be long lasting. So now number of propellers. Okay, number of propellers, more, many. Okay, more. In diagram before you see how many propellers you, so you must write more number than shown in the diagram. More, many. For what reason? To produce larger forward thrust. So the submarine will accelerate at a higher, will have a higher acceleration. Okay, and then component used to control, student, the position of the submarine. What component can we use? It has a special tank which is called the ballast tank. Dia ada satu bahagian yang special, kita panggil dia tangki ballast tank. So how this is enable the submarine to float or submerge into water. So when the submarine need to float, the ballast tank will be empty. So they reduce the total weight of the submarine. If the submarine is about to dive deeper, so the ballast tank will be filled with water. So it will increase the total weight of the submarine, then it will be submerged deeper. Alright, so this is the suggestion for the recommendation for the answer on modification on submarine, so it can move at higher acceleration and can be submerged or float easily. Alright, okay. Okay, now let us move to the second practices. This is our final practices for today. This is the question taken from your textbook, student. Formative practice 2.2. So for those who's having this homework, okay, you can refer to the discussion of answers here as well. Okay, first question. Explain the existence of atmospheric pressure. How can we explain that atmospheric pressure exists? So atmospheric pressure is the pressure due to the weight of the layer of air acting on the surface of the earth. Okay, this is the existence. Okay, atmospheric pressure is actually the pressure due to the weight of, since there is a layer of air exists around our earth, so this weight of layers of air which acting on the surface of the earth will produce atmospheric pressure. Alright, okay, second question. The height of the mercury column in a barometer is 756 millimeter mercury on a cloudy day. Pada hari yang mendung, dia kata ketinggian turus mercury dalam sebuah barometer adalah 756 millimeter mercury. Okay, you have to calculate the atmospheric pressure at that time in Pascal. So this is conversion of unit. Anda kena hitung tekanan atmosfera pada waktu itu dalam unit Pascal. So dia bagi sini unit millimeter mercury. So you have to convert millimeter mercury into Pascal. So how to do the conversion? They give you here the information. The density of the mercury is 13,600 kilogram per cubic meter, and the gravitational acceleration G is given 9.81 meter per second squared. So how do we convert from millimeter mercury into Pascal? This is the way. Okay, first, atmospheric pressure given in this question is 756 millimeter mercury. Okay, first you convert because Pascal, 1 Pascal equal to 1 Newton per meter squared. Okay, so millimeter we have to convert into meter first. Okay, so atmospheric pressure is 0.756 meter mercury. Second, we understand atmospheric pressure in Pascal is H rho G. This is the formula for atmospheric pressure in a unit Pascal. H rho G. H is the height of mercury column, rho is the density of the mercury, and G is gravitational acceleration. So now we do the substitution. Okay, H is 0.756 meter mercury. This is the density, 13,600 kilogram per cubic meter, and the gravitational acceleration, 9.81 meter per second squared. So the atmospheric pressure in a unit Pascal is equal to 100,862.496 Pascal. Okay, which means 756 millimeter mercury is equal to 100,862.496 Pascal. Alright? Okay. Okay, third questions. Okay, third question, student. What is the actual pressure at a depth of 125 meter in a dam? Okay, state your answer in a unit of meter, water, and Pascal. Okay, so untuk soalan ini dia minta anda hitung tekanan sebenar pada kedalaman 125 meter di sebuah empangan. Okay, nyatakan jawapan dalam 2 unit. Pertama dia nak unit meter air, yang kedua dalam unit Pascal. Okay, so you must put your answer in 2 different unit. One is the meter water, second is in Pascal. Okay, so this is the information you are given. Atmospheric pressure 1 atm also equal to 10.3 meter water. Okay, density of water is given 1000 kilogram per cubic meter. Gravitational acceleration G 9.81 meter per second squared. Okay, first, this is the actual pressure. Actual pressure in meter water is equal to water pressure plus atmospheric pressure. Student, remember, if I draw the dam for you, okay, let's say this is our water dam. Okay, let's say this is the depth. This is the depth, 125 meter. Okay, at this point, 125 meter. Okay, so this is the point where you have to find the pressure at. Okay, how to find the pressure here? First, there is atmospheric pressure acting on top. So this is the first pressure, atmospheric pressure. Second is the pressure due to the water at this depth. Okay, this is the second pressure. Okay, so this is rho Hg. Okay, so to find the total pressure or the actual pressure here, we have to find the sum of these two pressure. Atmospheric pressure plus water pressure. Alright, so the answer, how to find the answer? So in unit of meter water, it is 125. Okay, 125, this is the depth, 125 meter plus 10.3. 10.3 is up here. Okay, atmospheric pressure is 10.3 meter water acting on top, and then another 125 acting at this depth. So the answer is 135.3 meter water. Alright, while in Pascal, okay, in Pascal, okay, so this is the pressure in Pascal. Okay, actually this one is H. Okay, H rho G, the height depth. 135.3 meter multiply the density of the water 1000 multiply gravitational acceleration 9.81. Alright, okay. So the answer is 1,327,293 Pascal. So by this, we have solved all problem in formative practice 2.2, or you can put in standard notation. It will be 1.327 times 10⁶ Pascal. All right. Okay, so I guess that's all for today. Alhamdulillah, we have finished our discussion for today. Cikgu rasa itu saja masa yang kita ada untuk hari ini. So I hope this discussion can help you to understand 2.2 atmospheric pressure in a better way. Cikgu harap apa yang cikgu bincang lebih kurang 1 jam ini bantu anda untuk faham tajuk ini dengan lebih baik. Jangan lupa tonton semula video ini untuk dapatkan jawapan yang penuh untuk modul yang cikgu kongsi pada live chat ini. Okay, so you can get this module for free, print them out and write all the answer according to the discussion in this video later on. Bila-bila free, boleh tonton semula video ini untuk dapatkan jawapan yang penuh. So again, thank you very much for your time. Thank you very much for your effort. I really appreciate your presence today. Terima kasih banyak-banyak di atas masa dan usaha yang anda berikan, dan terima kasih kerana mengikuti kelas Cikgu Hasnitah. InsyaAllah kita jumpa lagi pada minggu hadapan, hari yang sama, hari Ahad 11 pagi. Okay, don't forget to join me again next week. We will continue with the next content standard 2.3 gas pressure, Sunday 11 AM. So akhir kata, selamat berpuasa kepada semua yang beragama Islam dan selamat berhujung minggu. So Assalamualaikum, salam sejahtera dan jumpa lagi. Bye everyone.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Marah semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.